All right, let the joy of learning begin. We are here, even though it is 4-6, we're kind of revisiting something we didn't take time to do when we were back in chapter 4. And that fun thing is called complex numbers. Not because it's really complicated, but because I don't know why. All right, so what we're going to be talking about today is simplifying expressions. I always love the verbs, simplify expressions. And then we're also going to be dividing. We're going to learn some operations as well. So I'm going to call that kind of simplify and then perform operations, which is really a fancy way of saying things like add, subtract, multiply. It's going to be really reminiscent of what we did with radicals because there is a relationship between complex numbers and radicals. Foreshadowing. Okay, here is a picture. All right then. So let's move on. Complex numbers. So back in the day, we learned to count, and that was very exciting. And then we learned that there were numbers that were in between our counting numbers that were fractions. We were like, wow, mind blown. Pretty soon you learned that there were numbers that were less than nothing, called negative numbers. So as you've gone through your math experiences, you kind of learned about other number systems that you didn't know existed until you needed them to do something, or until you kind of got to a point where you were ready to learn it. So at this point, if we've had a problem like this in the past, and we did these back in chapter 4, so dig deep, we need to isolate the x squared. So we would divide by -3. We would have x squared equals -9. And then our next move would be to incorporate a square root sign, plus or minus, to both sides. This cancels and everybody's hunky-dory. But then here, it's like, hey, sad face, I don't know how to take the square root of a negative. And so maybe at the time you thought that was happy face. And you would say, hey, there's no solution to that. Well, the reality is there's no real solution to that. But lucky for you, some mathematicians sat around and figured out how to get past that hurdle. So let's learn how. Thank you, mathematicians. So complex numbers, day 1, haha, we don't need that. So mathematicians created an expanded system of numbers, like I was saying, using I. So it's like a little italicized I. If you look at your calculator, your graphing calculator that you paid $100 for, so blow the dust off that, on the decimal button, the second function is going to be that little I. So just know that you can ultimately do a lot of calculations using I with your calculator, like on the ACT, but you still want to have a conceptual idea of what it is. So basically it allows you to do two things. And there's two building blocks to imaginary number success. The imaginary number, which is an unfortunate name because it makes you think that it's not something that you should really know, understand, or care about. But mermaids are imaginary and you should care about them too. So here, this is the building block. So they solved your problem. Thank them very much. When you have the square root of a negative, you no longer have to say, oh, there is no solution to that, because there is. So anytime you have the square root of a negative, you can now take that out as an I. So when I used to say, okay, the square root of 4, I would say, oh, that doesn't have a solution because I can't take the square root of a negative. Well, now you're thinking of that as the square root of 4 times the square root of -1, which is defined by our mathematician friends as I. So the square root of 4 comes out as a 2. The square root of -1 comes out as an I, and your answer to that would be 2I. I always say the I indicates that there was a negative under the radical. So that's one building block. The other building block that you need to know is that I squared is equal to -1. So I am here to tell you that you want to never leave I squared in an answer, because it's not done. If you have an I squared in your answer, you should translate it into a -1 and go from there. So this is something that you really want to know, because that's going to be the number one mistake. Like I always say, if you're handing in a test and they have I squareds in your answer, you can just go ahead and mark those things wrong. So what does that look like? How do they figure that out? Well, let's try it. Here I am with I squared. Okay, well, squared means multiplied by itself. So that means I'm going to have an I times I. Okay, well, in the previous step, we learned that I is defined as the square root of negative 1. And back in chapter 4, or maybe even earlier, I can't recall because I'm old, we learned that the square root of something times the square root of that same thing is that value. So for example, root 2 times root 2 is 2. Root 3 times root 3 is 3. So in this case, root negative 1 times root negative 1 is negative 1. So these are your two building blocks that you want to put into your brain and know from now on that I is going to allow you to take the square root of a negative, and I squared is going to always be replaced mathematically by the value of negative 1. So let's revisit our earlier problem. I still go through the same steps. I still get to the same point. I still need to incorporate a square root sign, plus or minus over here. This still cancels, and I still get to this point, but I no longer have a sad face. Now I have a smiley face, and I think, oh, I know how to do that, because I can think of that as the square root of 9 times the square root of negative 1. Everybody in the universe in honors math knows that the square root of 9 is a 3, and everybody in the universe who's watching this video knows that the square root of negative 1 is I. So if you have an I in your answer, it simply indicates that back in your process, you were taking the square root of a negative. Don't get I happy. A lot of people think, oh, I'm doing imaginary numbers. I'm just going to put I in all my answers. That's not how it works. The only time you'll have an I is if you had a square root in, underneath the radical while you were simplifying. So the rules of simplifying, speaking of my verb, simplify, the rules of simplifying stay the same as when we were doing radicals. I have to look at the square and think, okay, what does this break down into? Well, this one actually breaks into the perfect square, 36, and then I've got a negative, which is a negative 1. So this comes out as a 6, this comes out as an I, so that simplifies to 6I. Here, 50 is not a perfect square, so I start thinking, okay, well, that's going to give me 25 times 2, but then I also have a negative. This will come out as a 5. This will come out as an I, and then the only thing stuck under the radical is the 2. So you write the whole number part that you get from any perfect squares, like 25, out in front. Any numbers that get stuck under the radical because they're not perfect squares stay under the radical. And then here where I had my negative 1, that becomes an I, and because it's getting rid of the radical, it comes out in front with the 5. Alrighty, we know what squared means. It means to take 7I times itself. I'd multiply the 7s, and I'd multiply the I's. You treat the I's like X's until they're squared. Once they're squared, you go back up here and say, hey, I have this fun fact to remember, which is I can't leave an I squared in my answer because I squared has the value of negative 1. And so the correct answer to this problem when it's all simplified is negative because of the I squared and 49 because 7 times 7. Alrighty. So what if it does get more complex? Meaning all that means is that you have a two-part number. You have a real part and then an imaginary part. And a complex number is written in this format. A plus, and sometimes it's minus, BI. A is the real part because there's no imaginary number. And then whatever this is going to be your imaginary part, which is easy to remember because it has an I as in imaginary. So these are all complex numbers. This has a real part of 3 and an imaginary part of 2I. So let's just go down this list. What's real? and what's imaginary. So here, the 3 is real, the positive 2i is imaginary. In this example, the 7 is real and the negative 4i is imaginary. So that sign, the plus or minus, goes with the imaginary part. Here my real part is 14 and my imaginary part is 0i. Well, that's suspiciously like the number 14, but if you're told to write it in complex number form, you'd have to indicate that you understand it's supposed to have an imaginary number part. It just doesn't because it's 0. Same thing here. The real part here is 0 and the imaginary part, negative 2i. So you're just identifying the pieces of that complex number. So let's do some good old operations. Operations are nothing more than add, subtract. We're going to be combining real like terms. So you're going to combine the real parts because they're alike. And then you're going to combine the imaginary parts because they're alike. This is where I always say, and I mentioned it earlier, treat I just like you would an X. So don't get all freaked out. Just treat it like an X until you have an I squared. X squared is fine, but I squared has a mathematical value of negative 1. So just treat it like X until you get an I squared, at which point you better transfer that over to a negative 1. And then it's going to tell me to write my answers in complex form. So I have to pay attention to writing it in the ways that we saw up here. We can do that. Sounds easy. So don't go into this panicking thinking it's going to be difficult. Just do exactly what you would do if it was X's. Now I'm supposed to combine like terms. So 8 plus 5 is going to become 13. A negative I plus a 4i is going to be a 3i. I double checked my answer. I don't have any I squareds. I did it just as if it was an X, except I used i's, and I'm done. The same thing here that we worried about with X's, we're going to worry about with the i's. When you distribute a negative, it's going to change that to a minus, and this will actually become positive because the negative distributes and cancels. But then I'm really doing the same thing. I'm combining like terms. So my 7 and my negative 3 combine to be 4. Then my negative 6i and my now positive 6i actually cancel out. But this says to write it in proper complex form, so I still have to indicate that I know I'm supposed to write it in complex form, but that second thing is a 0. There is no imaginary part because they canceled out as a positive and a negative 6i. What would you do here? Same thing. You would distribute the negative, so you'd be right here. And then you would combine like terms. Well, these are both real, so they become 4. These are both imaginary, so just as if I had had a negative 7x plus 4x, I just say, oh, that's going to go together to be negative 3, and then it would be an I instead of an X in this case. Okay, well, I didn't encounter any I squareds, so that part was pretty easy. Well, that's because I was just adding and subtracting. Let's get into some multiplying or foiling. So here, like I said earlier, you can never leave I squared. This is where that's actually going to happen. You're still just going to do what you would do normally with X's. Clearly, if you have something up in front of parentheses, you know to distribute. 4i times negative 6 will be negative 24i. 4i times I will be a positive 4i squared. Okay, well, there's two things we haven't done. We have an I squared and we haven't written it in proper form. So the I squared has a value of negative 1, so that means that this is going to have a negative 1 because I squared is negative 1. So I have a 4 times a negative 1, which makes the overall value of this a negative 4. So when I go to do what it says, which is write it in proper complex form, I need to put my real part, which was the negative 4, and then my imaginary part, which is the negative 24i. So you just have to do a little bit more thinking and kind of organizing to keep track of all your pieces. Here, you're not going to do anything differently than you would have normally done. You're going to FOIL. So first, outside, inside, those become positive, and last. Okay, so there's something different here than foiling, and that's going to be right over here because I can't leave an I squared. So I have a minus 14, and then that's basically getting multiplied by a negative 1 because it's 14 times I squared. Well, that's going to actually technically have a value then of positive 14 because the negatives will cancel. And then my positive 14 can then combine with my negative 36. So I'm going to have negative 22 as my real part. And then these are both imaginary, so I'm just going to go ahead and combine them like I would if I had x's. And I'm going to say, okay, that's going to become positive 71i. It's not squared because I'm just collecting like terms. I am not multiplying. All right, go ahead and FOIL this thing out. First, outside, inside, last. This is the same as negative 1 because I have my subtraction and then my I squared has a value of negative 1. So it actually becomes a positive 1. That positive 1 combines back with the other real part to become a 5. Then I've got a negative 2i and a positive 2i that cancel out, but I've been told to write it in proper complex number form. So I still have to put plus 0i so the world knows I'm using complex numbers, but I didn't end up with a complex number part. Here, they multiply to be negative 15i squared, but I squared has a value of negative 1, so they combine to be 15, but following my instructions, I would write that as 15 plus 0i, since it said to write your answer in proper a plus bi complex form. All right, grand finale. Because our I is representing a square root, and we learned that you can't have square roots in the denominator, you still can't. So you can't have I in the denominator. So to get rid of it, just like when we were doing radicals, we're going to use what's called the conjugate. When you do the conjugate, you're going to change the sign of the bi part only. So if my original is 2 plus 3i, the conjugate, will be 2 minus 3i. If my original is 4 minus 5i, the conjugate will be 4 plus 5i. And lastly, if I have a 7i, keep in mind that since conjugate changes the sign of the I, this will become a negative 7i as my conjugate. So when I go to do this, I have to multiply the numerator and denominator, which basically means the top and the bottom of your fraction, by that conjugate. Why? Because it works. So let's look here. 2i, its conjugate, negative 2i. To keep the world peace, I have to multiply the top and bottom of the fraction by the same thing. The top, 7 times negative 2i, becomes negative 14i. The bottom, 2 times negative 2 is negative 4, but I times I is I squared. Can't have an I squared, because I squared has the value of negative 1. So it becomes negative 14i over positive 4. And then you just need to do what you do with regular math and simplify this number down to negative 7 halves, and then the I can go on top with that 7, or you might see it written as negative 7 halves I. But sneak attack, it says write in standard complex form. So I better indicate in my final answer, I better say, okay, that means I don't have a real part, but I do have a minus 7 halves for the I part. Picky details. All right. So think what your conjugate's going to be. Conjugate at the bottom would be 4 plus I. And then I'm going to have to do the same thing on the top. So this is where our practicing the multiplying comes in, because on the top, I'll distribute, which will give me 12I plus 3I squared. This is the same as 3 times negative 1. So when it's all said and done for the top part, my real part is a negative 3 plus 12I. That is all for the top. So let's take a look through the math on the bottom. This part right here, which I'm going to need to FOIL. Alrighty, so it starts off as first, so 4 times 4. Outside would be 4I. Inside, negative 4I. And then last is a negative I squared. Now, this is always going to happen on the bottom because that's why you chose the conjugate. It has to cancel out. We got to get rid of all the i's. Keeping in mind that this is really a minus negative 1, which is really a 1. So when I'm all done, I've got negative 3 plus 12i on the top over, and actually I'm going to write them as, well, 16 from here plus 1, so 17. I'm not going to be real picky about this, but technically you would write that as negative 3 over 17 plus 12 over 17i. You would separate them out so that you have that true a plus or minus bi form. All right. So you can see this last one's going to be a doozy. We've been going for a while, so it's going to be tricky to concentrate. So luck for you, it's a video and you can watch it in parts. I need the conjugate of the denominator, so think about what the conjugate of 3 plus 3i is. Use it on the bottom and the top to keep the math world in balance. I'm going to go ahead and FOIL the top up here just so I can see it. There's clearly not enough room to work because there's this very funny little cartoon down here. Okay, so I'm going to FOIL the top. First, outside, inside, last. That's doing these. This is going to be the equivalent of 6 times negative 1, so negative 6. So when I'm done with the top, I'm going to have a negative 6 combining with a 21, so 15. Maybe we'll move that down a little bit. And then my imaginaries in the middle combine to be minus 8i. All right, how about the bottom? FOIL that out. 3 times 3, so my first, then my outside, then my inside, then my last. As planned, these cancel. This ends up having a numeric value of positive 3. So this can combine with the other number I have, and it all is over 12. So I'm going to split it up. 15 over 12 minus 8 over 12i. But I'm in honors math, so I'm going to go ahead and take this and simplify each piece. 15 over 12 reduces to 5/4. Sorry, 8 over 12 is going to reduce to 2/3 I. So that is a lot of information, but basically it is just combining like terms, treating x, I like an x, the only thing you have to be cautious of is when you get an I squared, that you work in that fact that I squared is -1. So now you are experts on imaginary numbers. You're welcome.